Let's do some more examples with inverse functions and evaluating. So the first thing, and I've mentioned this a little bit already, is that you can use a calculator for many problems. Now, obviously, you have to make sure that 1/4, and in this case, negative 9.65, would actually be in the domain of these inverse functions. But if they are, your calculator will spit out an answer for you. Let me bring that up for you. So here, again, I just have my calculator app. My inverse sine function is right here. So I hit second sine, and that gives me on my calculator the inverse sine function. I type in 1/4, and I get my answer there. Now, you do want to make sure you're in the right form. We're using radians here, so you can always check your mode to make sure that the radians piece is highlighted. So just make sure you're in the right mode. And then we get approximately 0.252, we'll say 7, rounding to 4 decimal places. And I can do something similar for my inverse tangent. So second inverse, hit that tan key, negative 9.65. You do want to be careful on the TI 8384 series, the app and the calculators. You want to make sure that you use the negative symbol, not the minus sign. A lot of times you'll get an error if you try to use a minus for a negative. So you just want to be careful there. And I get about negative 1.46, we'll say 75. All right, so we can, again, use our calculator very quickly. And oftentimes, if something is not in the domain, your calculator will likely just give you an error message. So although you do want to be a little bit careful, usually, so for instance, if I did something like inverse sine of 3, you can see I got an error message because 3 is not in the domain of the inverse sine function. If you remember, for the inverse sine function, you're only going between negative 1 and 1 for your x values there, or for your inputs. So I got an error message, and that will usually be the case on most calculators, as they will give you an error message if it doesn't work. Now, one other thing I want to mention here, and I mentioned this briefly and said we kind of come back to it a little bit later, is composition of functions, particularly inverse functions. So when we plug an inverse function into a function, or the other way around, the function into the inverse function. So this is composition. We plug one function into another. They cancel each other out, and they leave us with just the input value, just the x. This also works for trig functions, but you do have to be really careful about the domain here. And this is where it gets tricky. It's not as straightforward as most regular functions because you have so many domain restrictions with your trig functions. So when we're composing with sine on the outside and then inverse sine on the inside, again, they do cancel, but it's only for x values between negative 1 and 1. And when we reverse the order, this only works for x values between negative pi over 2 and positive pi over 2. And then you have similar restrictions with cosine and tangent. So when we're composing with cosine, if cosine is on the outside, our x values have to be between negative 1 and 1. Or when the inverse function is on the outside, our x values are between 0 and pi. And then for tangent, the first one's really nice. Your x value can be anything, so we don't have to worry about it here. But if your inverse function is on the outside, it's only valid between negative pi over 2 and positive pi over 2. And you want to note there that this does have parentheses. So when you have parentheses, the n values are not included. Whereas when you have brackets, remember the n values are included in interval notation. And I'm just going to plug my computer in. Give me 1 second. Thanks for your patience there. Oh, my cords are a little bit tangled up. Okay, so let's try some examples. And the first one is actually going to be straightforward. So here we're composing sine and inverse sine. So they should cancel each other out. And I have the inverse sine on the outside. So this is valid only if x is between negative pi over 2 and positive pi over 2. Well, pi over 4 is between those two values. if you need to draw a number line or just use your calculator and figure that out, you can, but pi over 4 is between negative pi over 2 and positive pi over 2. So I can go ahead and use this. And those inverse sine functions are going to, those two functions are going to cancel. And my answer is just pi over 4. So when it's in the domain, it's very, very quick and easy to go ahead and figure this out. Second example, we're set up the same way, but I want you to notice that 5 pi over 4 is not in between negative pi over 2 and positive pi over 2. And if you're having trouble with that, you can just use your calculator to check. Obviously, this is positive, so I don't have to worry about the negative side. But pi over 2 is about 1.57. And 5 pi divided by 4 is about 3.92. So that's definitely outside the range. So I can't just cancel things out. What I need to do is I need to find a way to work with this first. And there's different ways to do that, but one way is to try to get this angle to be in between negative pi over 2 and positive pi over 2. And to do that, I could use reference angles. So again, you don't have to, but sometimes it's nice to draw just a little picture here and think about what's going on. So here's my starting side, and I'm going to 5 pi over 4. This is over pi, so it's pi would be like 180 degrees. So it's kind of like right here is where my angle's going. So this is my angle here. That 5 pi over 4. So what I can do there is I could use a reference angle instead. That can be helpful to help me figure this part out. So here, that 5 pi over 4, we're in the third quadrant. You do want to remember that in the third quadrant, sine is negative. Right, remember sine refers to the y values on the unit circle, so all those y values would be negative down there. And then I can use the reference angle, and my reference angle would be this one right here, connecting up to the positive x-axis. So that reference angle there, I would just take that 5 pi over 4 and subtract out pi. And what happens is you're left with just pi over 4. So this piece here becomes sine of pi over 4. But again, do remember that it's negative because we were in the third quadrant. So it would be negative, that reference angle. And then sine of pi over 4 is root 2 over 2. That's a common one that we know. This would be negative root 2 over 2. And now we can go ahead and just answer this. So again, if it's not in the domain, we have a bit of work to do. You have to find another way to get the answer. You could also just find sine of 5 pi over 4. If that's one that you're very comfortable with already, you don't have to use a reference angle there. If you happen to just know that one, you know that that's negative root 2 over 2, then you can just jump right to there and skip the reference angle part. That's okay as well. But either way, you have to find a way to get this to this. So we do have to clean it up kind of a little bit more manually here. We can't just cancel. Now, negative root 2 over 2 is fine. It is in the range of values that we need for inverse sine. And what you could do there is you could go back to your table, go back to that unit circle, whatever we did in the previous two videos to figure out that inverse. And what you get there is negative pi over 4. Okay, so again, one thing you could do there is go back to your table and you could use that table to help you find the exact value if you need. So one strategy there, or again, using the unit circle. So if you're not in the domain, it is a bit more work. You do have to be really careful there. All right, let's just do a couple more of this style. And again, we're going to find the exact value. So we're going to do sine of cosine inverse of 0.6. So if I go back to my sheet here, I see cosine is first. So cosine inverse does cancel if your x value is between -1 and 1. Well, my x value is 0.6 here, which is fine. So this is a nice, easy one. And my answer is just going to be 0.6. For the next one, doing another sine one here. So I have inverse sine first. Okay, so inverse sine of sine works when our x value is between negative pi over 2 and positive pi over 2. So again, this 3 pi over 2 is too big. I can't just cancel them. This is not going to be an easy one. I'm going to have to do a little bit of work first. So the first thing we have to do is we do have to figure out sine of 3 pi over 2. And again, you can do this a few different ways. If this is a value that you're already pretty comfortable with and you know that answer, you could jump right to the answer. If you don't know that answer, then you could draw a little unit circle and kind of figure out where that is. So if I just draw a quick unit circle, right? This is pi over 2. This is pi. We're definitely bigger than that. This is 3 pi over 2. So 3 pi over 2 happens to be exactly 270 degrees. And that point on the unit circle there is 0, -1. Now remember, your sine value refers to the y value here. So this value is just -1. Now, the inverse sine function of -1, we can go ahead and do that. That is in the domain for the inverse function. And again, you can take out a little chart here, or you could use the unit circle, and the answer there is going to be negative pi over 2. And let's do one more. So we'll do cosine of cosine -1 of 1.5. So if I look at my chart here for composition, if I do cosine of inverse cosine, well, my value has to be between -1 and 1. So 1.5 is not between -1 and 1. And this one's actually a little bit even trickier, because if you think about this, we can't actually do it at all. So if you go back, I'm going to go back through my notes here to just the regular inverse function, right? Cosine inverse function here. Well, your input has to be between -1 to 1. That's it. You can't go beyond that. This is not like an angle that rotates around. This is the y values on the cosine function. So you're restricted there. So it's just not going to work at all. So this value here really is not, it doesn't exist. It's not defined. And that's because this is not defined. So it is definitely outside that range there. Or that 1.5 is outside the domain of the inverse cosine function, which is outside the range of the cosine function, right? That 1 to -1. So this one here, we actually cannot do at all. So they can get really tricky. You have to really think about these. The ones that work are really easy and fast, and the ones that don't work really require you to think about what you already know and use all of those techniques. So if there's values that you've just memorized, you have a table somewhere, you could use that. If you need to draw a picture to help you remember where that value is, you can do that as well. And again, you can also refer back to graphs or the initial definitions to make sure that something actually is in the domain there. And here we do have an issue.